Hi, hi everyone. Thank you for joining us. This is Fei Zheng. Very glad to be here. The webinar today is one of the IAMAS Earlier Career Scientist webinar series. If you are interested in IAMAS webinars, you can subscribe to our YouTube channel. Here you can find all the webinars from the YouTube channel. And here also you can subscribe to our IAMAS WeChat account. And this webinar today is co-organized by CNCFE and Future Earth Global Sector Hub China. And thanks for Future Earth. Okay, today we are very honored to invite Professor LiQingXiang from Sanyasang University to give us a talk about differences in persistence in explain the unevenness of warming at continental scales. Very glad to invite Professor LiQingXiang. Professor Li, could you please share your report? Okay.
Can you see me at my PPT?
Yes.
LiQingXiang from IAMAS University. I'm glad to share you with one of our recent studies here. The topic is different climate response persistence causes warming trend unevenness at continental scales. Although this work has been accepted to publish in Nature Climate Change in last month, there's yet a lot of things need to be further addressed. So I hope that you will give more comments and suggestions, and you're welcome to join us to conduct cooperation research on this issue. It is well known that the global warming in the 20th century can be attributed to external forces, but as we know, the global warming is not uniform, but has distinct regional characters. However, the causes of this regional warming unevenness is not fully understood. This is a very important topic because it involves regional emissions of greenhouse gases and atmospheric pollution and their resulting impacts, also climate change negotiations. Therefore, this paper discussed the cost of this warming unevenness arising from the two largest greenhouse gas emitters, China and the United States. The global surface temperature benchmark dataset we use is China Global Merged Surface Temperature interim version, which was developed by ourselves. It is a combination of our self-developed China Global Land Surface Air Temperature 2.0 and NOAA's extended reconstruction sea surface temperature, which was used by IPCC AR6 released in last August. While AR6 also indicates that the CMST warming trend estimates in the Arctic are still likely to be underestimated. Therefore, we have recently considered this problem carefully again and updated the CMST interim to CMST 2.0. This table gives a combination between CMST 2.0 and CMST interim. In CMST 2.0, we constructed the temperature of the sea ice.
我不打电话呀，也不能听到你吵。
Maximum ice surface and medium ice surface, and we systematically evaluated the parameter uncertainties and the reconstruction uncertainty. The article on the CMST 2.0 is in the discussion of the ESSD. It is expected to be accepted for publication this month. You are also welcome to use the new versions of CMST 2.0. The dataset has about the same accuracy as RCIU temperature, non-room temperature, property as and the gas temperature. And it has been accepted as the fifth global surface temperature benchmark dataset by AR6 and international colleagues. The figure on the right also shows several datasets have higher consistency in spatial and temporal characters. We first compare the distribution of the land surface air temperature trend in North Hemisphere since 1900. It is clear. It clearly appears that the warming trend is higher in the China than in the U.S. region. As is more clear from the plot with latitude mean removed. the below plot. Yeah, and this is the trend, and it's uncertainties. Yeah. Yeah, we use two methods to separate the external force signals and the noise from the whole warming. Yeah, the first method is one realization MME of CMIP6 that is often used. Obviously, and the signal of the external forces separated by this method is very consistent with observed long-term variability. This is MME. The black line is observation. Yeah. The second method is a combined statistical model of MLR and AMA, recently developed by ourselves. Yeah, these two papers they are published in last year and the year before last. This combined model is based on an idea by Hassan in 1976. Climate is stochastic and noise-driven, but fairly linear. Very coincidentally, during the submission of this article, Hassan won the 2021 Nobel Prize in Physics in October. Yeah, our related articles is published in Chinese Science Bulletin and Environment Research Letters. Yeah. From the conclusion of the global surface temperature study, these two pictures, our method agree well with the classical optimal fingerprint at the global scales. Yeah, this is very similar. However, at the regional scales, we can find that external forces signal obtained from multimodal MME is not at all representative of the observed long-term changes. The MME warming in the US is obviously larger than in China, which is opposite to the observations. Further, we also looked at the models used in large sample experiments, and the results are very similar with those from one realization MME. So, taken together, the model simulation of the external force signals are unsuccessful. Yeah, it is opposite to the observation. While our own compared models, they show a very good result. The external forces signal obtained are quite representative of the observed long-term changes in both China and the US. And the external force signal is significantly stronger in China. Yeah, while the this is not this didn't show the internal variability. Yeah, the external force is significantly stronger in China than US. Yeah, these two equations show the result of the compared model for each of the two countries. And this is the result for the large sample models. This slide gives the external forces signal and the internal variability is separated by our compared model. Yeah. And the internal variability is further decomposed by the MMD, the MMD. That shows some difference between the multiple scales extracted from a the multi-decadal scales period is different between China and the US. So this is more supportive of McMahon's recent conclusion that the AMOs may be related to the impacts of the internal forces. The persistence, we compared the persistence between China and the US. The persistence includes short-term persistence and long-term persistence. We often talk about the memory of the oceans in terms of short-term persistence, but the persistence here is a long-term persistence, which is related to the complex ocean and mass-spherical coupling, and is enhanced on interdecadal to multi-decadal scales. It is related to the memory of the weather, which also receives mainly the modulation of oceanic memory. It has a clear contribution to the trend of the climate series. We found that the persistence explains a lot of the warming trend in terms of temperature series in itself. So the temperature series are both red noises. The autocorrelation function and the autocorrelation function are always used to show the persistence. Obviously, when we look at the 100-year ACF and the PSF of the series, this is ACF and this is PSF, which shows that the persistence of China, temperature series is significantly stronger than that US temperature series. Both the ACF and the PSF. When we that there is a general law, it must be more than just the last 100 years. Now this law also appears on a longer time scale. So we looked at the 2000 years. Why look at 2000 years? The magnitude of the temperature change in the last 2000 years is relatively small. So we compared these two time scales. As a result, it appears that the persistence of temperature in China is stronger than the United States, both in the last 100 years and in the millennium scales. This is for millennium scales. This is a century scales. We also looked at the SIMP6 simulation result, and apparently it failed to simulate this persistence, the difference of the persistence again. This is China, and this is for US. The persistence is stronger in US than in China, the SIMP6 model. Some recent studies attribute the fast warming to the rapid urbanization in China since the second half of 20th century. But others still believe that the urbanization effect on China average surface air temperatures is detected only in limited areas, and the overall contribution is still very little and negligible. As we mentioned earlier, China's response to external forces is significantly stronger than the US region. And in the two equations, in our model, there's no urbanization items included. So we conclude that the urbanization should not be the main causes of this warming unevenness. We know that there are two main external forcing factors that affect temperature change. greenhouse gases and aerosol. Yeah. So which one actually at play? Yeah. The first we illustrated this method directly with two external analysis, 20th century analysis and CEI 20th century. These two analyses are both central scale data and neither of the assimilated satellite data and the surface aerosols. So the both do not contain the influence of the aerosols. We use them directly to calculate the temperature series of China and the United States. It is found that, yeah, they are not working, yeah, before 1950s, especially in China. In the United States, it's okay, yeah, but in China, they are not working. But after that, the simulators are okay, especially after 1970s. Yeah, the two analysis simulated the surface temperature very well. So it shows that the temperature series obtained from the analysis are very similar with observations, which means at least after 1970s, the aerosol contributes very little to the surface air temperature series in China and the United States. We also used optimal fingerprint to show the contribution of the aerosols. Yeah, we again use those previous models with the large samples to fingerprint the temperature response to aerosols, especially specifically in China and the United States. Yeah, the result from all models show that U.S. temperature response is significantly higher than China in the all as before. But if only aerosols are considered, the response for China and the US are almost the same. The null panel. Yeah. Yeah. We did an ensemble of all models, and the results are more convincing. The role of the aerosol is very similar. To summarize, the response of temperature to external forcing obtained in this paper is actually the response to GHG, yeah, greenhouse gases. This agree well with a paper in Nature Geoscience by Dr. Lin in Peking University and Dr. Wang in IIT group recently, yes. This slide gives the main conclusions of these studies. The first one is over different time scales, the warming rates of surface air temperature over China is significantly higher than that of the United States. The second is the 756 model overwhelmingly underestimated this unevenness of warming trend at continental scales. The third, based on a compared statistical model, it is shown that the contribution of the internal forcing of surface air temperature warming over China is larger. In contrast, the surface over the United States is more easily modulated by the internal variability. The last one is our analysis directly studied suggesting that urbanization is not the main reason for the apparent difference in the warming rate between China and the US. However, this can be explained in terms of persistence of surface air temperature response to external forces and of the internal variability. This work also suggests some insights. There's a certain uncertainty problem about the data, about the model, and this should be fully considered when making climate observations, detection, and distribution. Yeah, that's all that's all for my presentation. Thank you for your time. Thank you.
Professor Li. Very great presentation. Does anyone have some questions or suggestions?
Yeah, you can also write me emails telephones. Yeah, telephone me.
Yeah, and Professor Li, this work has already accepted by Nature Climate Change, right?
Yes.
Okay.
Maybe it will be online several days later.
Oh, okay. I think if we are interested, we can also read this paper.
Okay.
And I have two questions. One is about the data. You mentioned the air temperature data. Where can we find the and download the data?
Yeah, thank you. You're welcome to use use our surface temperature data. Yeah, the nearest best version is CMST 2.0 and CLSAT 2.0 ensemble. Yeah, this data sets are all put on the website. Yeah, in different websites, I think. The first is LiQingXiang, because we before we submitted the paper to the ESSD, we need to put the data in some website. Yeah, and also we have constructed our own website to share the data and some of the temperature series. Yeah, because it is not easy for a scientist to calculate the average, the global average surface temperature series or north hemispheric surface temperature series. Yeah, so we put the series in the inside.
Oh, okay. Thank you. And another question is, you mentioned the CMAP6 models show a, the difference between persistence between China and the US is not that obvious. Um, could you tell us some reasons about this CMAP6 bias?
Thank you. 76, yes, there's a very, we use the 52 models. Yeah. And as I showed just now, the first, we use the two methods. The first is the one realization. Each model one realization. Yeah, the 52 models ensemble mean. Yeah. And the second is we used about 10 models, 10 models with large ensembles. The large samples, the sample may be sample greater than 10 realization. Yeah. All most of these two approach did the wrong conclusions. I don't know why this bias come from, but it is the ensemble result. Yeah. for the models.
Okay.
Yeah.
Does anyone has some questions?
Yeah, thank you, Professor Lee.
Thank you.
Very interesting talk. Thank you. My question is, okay, the ground surface temperature data observed by the ground instruments or a compilation of the ground instruments and plus remote sensing satellites data?
Our data set is a benchmark data set, so we only use the instrument observation. Yeah, we don't use any satellite or model and other remote sensing. Yeah, we don't use that.
Okay,
So,
if the satellite data can be used, will that be or will that make a contribution or not?
The first, we don't use satellite because the first, the satellite is very short. Yeah, our data set is from 1850
Okay.
to present. Yeah. The second is we haven't used. If we only use the satellite during the recent decades, which will need some inhomogeneous. Yeah. So we don't use the satellite.
The satellite data are just available for the for the past a few decades only.
Yeah. Yes.
Does this make sense if say for the past a few decades to use satellite data plus the traditional data together? Does this make sense?
Because we focus on the China and the United States, so maybe the use of the satellite will not change much, I think. Yeah. Because during the recent decades, the observation is in higher density enough.
Okay. Okay. Thank you very much, Professor Lee.
You're welcome. Yeah.
Thank you.
Thank you.
Anyone has questions? If not, I think we thank Professor Lee for the sharing today. Thank you very much. And thank you everyone for joining us.
Thank you.
Thank you, Professor Lee.
Thank you.
Goodbye. Okay, goodbye. And good night.